Welcome back, Math 30-2. Today we are looking at our fifth lesson on exponential equations and functions. This is our last lesson before our test. Now, here we're looking at this. We're given a table, okay? And in this table, we're given the number of hours, and we just try and find a relation of what's happening. If we were to graph this, it would look something like this. So at 0, we'd have 50. At 1, we'd have 75. At 2, we'd have 112. At 3, we would be up to 169. 4, 253. Right there. Then at 5, we would be all the way up to 380 over there. So if I look at this equation, it makes a little graph like that. Now, how do I do that? It's going to be very hard to make an equation just given that data. Here, we're just going to use a calculator in your grade and figure out how to solve this. So from this equation below, what kind of equation is this? Well, this might be a parabolic looking like that, or so it could be a quadratic. It's definitely not linear, there's a curve. It's definitely not logarithm. Why? Because it intersects the y-axis, so it cannot be a logarithm. I'm going to say this is more likely a quadratic, or sorry, an exponential. It increases exponentially. It starts off slow, then it really shoots up. So we're going to say an exponential equation. Now, if you follow this here, the next 2 pages, I strongly encourage you to follow it. We'll show you how to create, if you read the rules, how to create the equation for this graph here as they follow through step by step. Now I'm going to start on another one here. We're going to look at this equation here. Okay, so here's the class example. I strongly encourage you to do the first one with the exponential equation. But now here's this equation. So here's the class example. It says, we're looking at carbon 14 and the years, okay? So now this one's looking at, it already gave you a hint there. It says it's a log function, but here's why. So first we're going to put this into our calculator and create a scatter plot. So first thing I do is I'm going to go turn on my calculator, go to the stat option, edit, and plug in all my numbers. So this here's my x, that's always the first column, and this here is my y, that is my second column, okay? Now, when I look at this, I'm going to quit, I'm going to go to my window first. The reason why I chose, the minimums doesn't matter here, you normally choose 0, I just left it at -10. But the reason why I chose 100 for my window is because my max for my x is 95, and I'm just going to go a little bit beyond my max and my x value. The reason why I chose, and now the minimum for my y I just said is -10 because it's something small, and I probably could have gone with 0 as well. But now looking at this, my y max, I said 11,000. The reason why I did that is I took my max and my y value, and that was right there, 10,000, almost 11,000. So I just went a little bit above both maximums. Okay, if I really wanted to be accurate, I could have even gone a little bit below both minimums. So here I could have gone 20, and here I could have gone maybe at 400. And we'll just see what that looks like if I did that. I could have gone positive 20 for my x min, and I could have even gone 400 for my y min. Then we're going to graph it, and we get a little thing that looks like this here. But looking at that now, we might see a little problem. Now what is that problem? Does this here look like a log or exponential? It's increasing and then it's going down. If I put this, I'm going to go back, my x to being 0, my y to being -10. And see what it looks like. If I follow this, right here, we go all the way down to there. It looks like it may eventually cross my x-axis, okay? So this one looks like it goes like this and then down that way. So for this one here, we are going to use, so create a scatter plot, we did that, and then logarithmic function appropriate for the middle. So I would say a logarithmic function is appropriate because we're going up here. It looks like it will never cross the x-axis, but here eventually it will cross the y-axis and then go over. Okay, so it looks like here it will eventually cross the x-axis. So therefore, this is a log graph. Now the next is, we're going to use the natural logarithm expression for this one. So that's the log regression. So we want a natural log regression. So I'm going to go into my stat, and I'm going to calculate. I'm going to go all the way down until I see that's a linear regression. A logarithmic regression. And I'm going to push enter. And we want my x value to be in list 1, and I put my x's in list 1. We said the y value is in list 2. And that's where I put all of my y values were in list 2. So everything looks good, and my frequency is okay, good. So I'm just going to push enter, enter, enter. Everything looks good. I'm going to calculate. And this will give me a lot of lag today in the video. I'm sorry for that. So this gives me my equation. So it says, write the function in that form of a plus b. So we have 3a 3 plus, well, it's going to be negative, plus negative 8264 x. And y equals, that is my equation. Alright? So now in our graphing calculator, it wants us to display both of these over the scattering plot. So I'm going to go here, and I'm going to go to, whoops, and we're going to go into statistics, and we're going to go into my equation, and we're using a regression equation. And that is this one right here. It's saying it is automatically a natural logarithm, because it's the last equation we used. We're going to graph it, and it goes in there. Because it wants to know what the variable is. Okay? And that's what it's going to look like. So the next one says, use the graph in C to answer the following questions. So bone fragment with the carved image of a mammoth was discovered in the southern United States of Florida on June 11th. If the carbon dating test indicated approximately 20.3% of carbon-14 was less, estimate the age of the fragment to the nearest 1,000 years. So I'm looking at the word problem here. So it says the percent of carbon was 20.3. Now the percent here refers to my x value. So all I'm going to do is, I'm just going to go into the stat plot now, and I'm going to take off my dots on the stat plot. This just makes it a little bit easier. So what I'm going to do is, I'm just going to trace, and we want to know when my x value, because percent is your x value, is 20.3. So I put trace, 20.3, enter. And I'm going to get 13,181 years. So it wants in the nearest 10,000 years, so it's going to be 13,000 years. So it's 13,000 years old approximately. Next one says, if the skeleton of a bison is around 10,000 years old, what percentage of the whole number of carbon-14 should the paleontologist find in the remaining bones left? So now we're given the years, right? And years refers to our y-axis. That's a problem. We can only trace the x-axis. So we're going to have to go to the y equals again. We're going to put in how high, what the value was for the y that we want. That's 10,000. We're going to graph it. And 10,000 is way up there. So now what we're going to do is, we know where the value is, and we want to know that intersect, because this intersection is on the graph where our graph is equal to 10,000. So I'm going to calculate my intersect, which is number 5. So we have our first curve, which is here. I'm just going to get somewhere near it. I know it's somewhere up there, but I'm not exactly on. It doesn't matter. Click enter, second curve, enter, third curve, enter. Just hit enter 3 times, and I get 29.8%. So I'm going to, and does it say to the bit? Fine. So I'm going to say around 30%. Oh, to the nearest whole number, 30% of the carbon-14 will be left. Okay? The last one says, compare your answers with class example number 4 in the previous lesson. So just compare it to your last lesson, and you should get something very similar. Well, good luck. I hope you understand how to use linear regressions using tables. You only do this when we're given tables and a bunch of data, and how to find the formula, and then how to calculate and solve your problem. So good luck. I'll see you tomorrow. Hopefully you have some good questions and we can work on this together.